Hi everyone, I'm Moxie, and in this lesson, we're moving from what you can see, that is, things like motion and heat, to what you can't see, but you use every single day. That is electricity and magnetism. They may be invisible, but they shape our entire world, from the light in your room to the phone in your hand. Have you ever rubbed a plastic comb on your hair and see it attract little pieces of paper? Or watch lightning flash across the sky and thought, wow, what is this? That is physics, the world of electric charges and magnetic forces at play. By the end of this lesson, you'll be able to, 1, explain what electric charges and magnetism are in simple terms. Number 2, you'll be able to understand how moving charges create electricity and magnetism. Number 3, you'll be able to recognize how electricity and magnetism combine to produce light. So, you see, when you switch on your light or charge your phone, do you ever wonder where that power actually comes from? Do you? After learning about motion, forces, and energy, physics now takes us into the invisible world. That is the world of charges and magnetism. You can't see electricity moving, but you can see what it does. You can't see magnetism moving, but you can see how it pulls things toward it, right? Now, when you combine both electricity and magnetism, something amazing happens. You create light. Yes, the very light that helps you see this lesson is made from electricity and magnetic energy dancing together, right? Now, a lot of physics is about understanding these invisible players. Telling you, every single thing, even your body, is made up of particles with electric charges. Every charge or these charges are everywhere. And when you have a large number of them, right, you get some pretty amazing effects. Now, for example, when charges build up on your clothes or hair, you get static electricity, which is that little zap when you touch a metal door. And when charges move, that is when you get electric current, which is the same electricity that powers your TV, your blender, and your phone. So to recap, still charges gives us static electricity, like lightning. Moving charges create what we call current electricity, like what flows through cables. And where there is electricity, there is also magnetism. That's why magnets can spin fans, run electric motors, and power loudspeakers. And when the two combines, right? When you combine the two, electricity and magnetism, you get one of the most powerful forces in physics, which is electromagnetism. It explains lightning, light bulbs, generators, electric trains, even how your phone screen lights up. In later lessons, we will go deeper into how electricity flows in currents and how components like resistors, capacitors, and inductors work. But for now, just know this. Every time you switch something on, a dance of invisible forces begins. Charges move, fields form, and light appears. That is physics' most magical expression, right? Now, we'll be right back after the break. Okay, let's pause for a moment and test what you've picked up so far, right? Question number 1. What happens when electric charges move? A, magnetism is created. B, heat increases. C, light disappears. D, static builds up. Question number 2. What is produced when electricity and magnetism combine? A. Sound. B. Light. C. Heat. D. Airflow. Now let's make it practical. Number 1, take a plastic comb and rub it on your dry hair for 10 seconds. Okay? Now, number 2, hold it near small pieces of papers. What happens? Number 3, write down your observation and explain it using the word electric charge. I would like to see what you come up with in the comment section. Even though you can't see electricity or magnetism, you can definitely see their effects. From lightning to your light bulb, they are two sides of the same coin, and together will make light itself possible. In our next and final part of this particular segment, we'll explore something truly mind-blowing: the wide side of physics. I am Moxie. Thank you for watching, and I'll see you in the next part.